yesterday.
No.
I understand there was some errors with getting back into the Stanford Lagunita.
Yeah, I
Is
had
what
to
it's called?
That's what it's called. I didn't know it.
It's the special section site. It's called Lagunita in Stanford. The issue is that when you guys sign up with your school email, not all emails are allowed to come through. I think you guys know that, right? They're filtered. And I forgot to add the exception or ask for the exception to be added. So it was added. So when you go to sign back in, just do that, forgot my password, so that it'll recover it for you. And then it'll send you, hopefully send it to you now, because it's already been put into the system. Unless you made a whole new account, then you should be good.
I did that. It wouldn't let me make an account.
Yeah,
And
so
it was like, I just remade it.
yeah, so just try to, if you haven't made it, make your account. Everybody else, just go back. And yeah. Yeah, I forgot. Just go with recover password, and it'll ask you for whatever information was there. Okay. So, bell work was kind of a little bit of what we did yesterday there. State the domain, and then try to simplify this problem. Anybody have it? Anybody come up with something? Want to share? What do you got, James?
Do you want this domain? Or
Yeah, let's do the domain first because that's easier, right?
The domain would be x not equal negative.
Or? Okay. So here's the question we need to ask ourselves, because I mean that's partially correct, half correct, I should say. When is the only time we would have a problem with a fraction? And we talked about it yesterday, right? What is that issue? Zero's where? On the bottom. So if you had a zero on the bottom of a fraction, that would make the whole fraction, what do we call it? Actually, it's undefined. Undefined. Irrational is when it goes on forever, right? So it would be undefined. So here's the question we're going to ask. I'm going to get rid of your answer for now. Actually, you know what? I'm going to move it away for now. We're going to put it there. No, because I like it. It's a good one. We'll put it in red. Okay, so we're going to ask this question. If this can't be 0, then when will x squared minus x minus 6 be equal to 0? So that I know what those numbers are, and I don't use them. Does that make sense? The question I just asked is, when will this, aka the denominator, be equal to 0? And then I'm going to find what those values of x are, so that I know what they are. Questions on what I did here? Simple algebra question you guys have done before, right? So this is saying, when is this going to equal 0? So let's solve it, and we'll use our great skills of factoring here. Is that cool? So let's go, and we'll do our factoring bit. 2 and 3, right? That would have to be a negative. This would have to be a positive. Does that work?
Yeah.
Yeah? Okay, so, and I forgot the name of it, but the question is, all right, I've got two numbers here. I've got some number times another number, and that was equal to 0. The only way that that can happen is if this number was 0. Yeah? And when will that number be 0? Only if x was equal to, bam, that's where he got one of them. You see it?
Can you not simplify that out? So,
Go ahead.
can you not simplify that further?
How?
So you'd have x minus 3 over x plus 2, x minus 3. You can cancel out x minus 3 on each side and just have 1 over x plus 2, no?
Are you talking about this?
We'll simplify the, what is it, factorial version?
Here?
Because you'd eliminate one of the domain restrictions, correct?
Right. Well, you have one of them, which was negative 2.
Yeah, but can't you eliminate positive 3?
Right. That's what we're going to go next. You were one step ahead of me. You're too good. You're just too good. So there's two scenarios here, right? It's either this number was 0. If this number was 0, that means that x would have to be negative 2. And the other scenario, absolutely right, is if this number was 0, correct? And when would this number be 0? If the value of x was 3. So the two numbers I cannot have in the denominator would be negative 2 and 3. And you can check that if you want. You plug them back in,
Ew.
and then see if you get zeros in there, or for the denominator, okay?
Okay, that's not
Questions on that? If you weren't here when we kind of went over it, on YouTube, J Munoz Math, yesterday's video is recorded on there, so you can go back and watch it if you need to, okay? You can just ask those questions if you missed any part of it. All right, cool. Questions on what I did there to get the domain? So, they ask me, what is the domain? I'm going to say, it's all numbers except for
Negative.
-2 or 3. All right? Cool. Now, let's simplify it. I do have x minus 3, and I've already factored the denominator, didn't I? You see it right here? It is x plus 2 times x minus 3. Is there anything that I can simplify? The x minus 3. This is a quantity, isn't it? It's just a number. There wasn't parentheses there because it wasn't being multiplied by anything, so they said, oh, we don't really need them. But it really is just some number. So this number and this number are exactly the same. They make a 1. So now, that problem simplified is simply going to be 1 over x plus 2. Does that change my domain restriction? It doesn't, huh? X still can't be -2. And I still want to stay with that 3 as well, because that was part of the original problem, wasn't it? I mean, if we simplify it, I could definitely have 3 in there. But from the original problem, then we have that domain restriction. Cool beans? Awesome. Anybody want to ask any questions? You guys process that for a minute? Okay.
Do we turn this in right now?
No.
Oh,
On your way out.
okay. Okay.
Okay. When I was in school, I'd be like, every semester, this is gonna be the best one. I'm gonna try so hard, right? And I'm gonna focus. And I'm like in focus mode in class. I'm like, yeah. And the teacher says something, and I'm like thinking about something else, like, yeah. And then I come back and I miss some stuff. Okay? That doesn't happen to you guys, I know that. But if you don't catch something the first time, ask. Okay? Don't sit there and be like, what the hell did he say? Okay? And I think I've said it to the other, last semester. It's kind of like, right now you're trying to stay afloat, huh? Trying to stay afloat, and then you look away and you're like, okay, I'm trying. And then Munoz keeps going, and then you're like, oh shoot. And then day 2, day 3, the first week, you're like, screw this, I'm done again. Okay, don't put yourself in that position, don't do that. Please ask the questions. I think I've said, I'm not going to get mad if you ask me a question of something I just said, because you don't understand it. It's when you're completely being douchebag? No, that's not the word.
It's douchebag.
Okay, whatever. You know what I mean. Like, if you're doing it on purpose, then I'm like, screw you, dude. But if you really have questions and you're asking, or you had one of those moments when you were processing and then you lost it, like, oh man, I'm sorry. I was thinking about something else. Can you repeat that? Yeah, definitely. Okay. Please do that. All right, cool. Let's get back to the lesson. We did that. We did that. Okay, this was it right here.
I'll just take something.
All right, cool. If you need to charge your computer, there's ports all the way across. I know there's 2 big ones in the back somewhere, and then there's this one in the middle that hits here, and it hits right back there. Yeah. Power up. We did these already. Boom. Okay. Quotient of opposites. In general, if the numerator and the denominator of a rational expression are opposites, then expressions equal -1. And here's what this is saying. You guys remember this one problem we did yesterday? Right here? See how they're opposites? That's positive R, that's a negative R. That's a -1, that's a positive 1. Those are opposites. Okay? So if you look at something like that, you're going to just say, oh, well, that's just -1. And I think we kind of proved it as we went through the problem, right? We ended up with factoring out the -1, 1 over 1. Oh, I get the 1. 1 divided by -1 is still just 1. So I guess a quick way of looking at it is examine this first part. And if the numerator and the denominator are opposites of each other, then that's just going to be a -1. Cool? A little shortcut. Cool beans. Moving on. Go back to what? Yeah, the last screen was yesterday's, right? You should have that. But if you need me to go back, I can. Anybody?
Nah, just leave it right.
Okay. Now go ahead and put up the example as well again. Two examples. See how that's q, negative q, 7, negative 7, that's a negative 1. Okay? Got negative 5a, positive 5a, positive 2b, negative 2b. Again, that's just a 1. Or negative 1, sorry. Notice these are not opposites down at the bottom. What would you call those? Conjugates, okay? Not opposites. In order for this to work, either this R or this R would have to be a negative, and then we would be good, but it's not, so not opposites, okay? All right, multiplying rational expressions. Did you need that? Sorry. Fortunately, multiplying rational expressions is everyone knows how to use the distributive property, right? Who does not? Okay. I don't want to put him in a blast there, but I want to make sure that you guys can do the distributive property. Because if you can do that, then you're going to be just fine with this. Because it really is just multiplying. You guys remember how to multiply 2/3 by 4/5? What does 2/3 times 4/5 equal? 8/15. How'd you do that? 4 times 2 or 2 times 4, right? And then 3 times the 5. Because with fractions, you can do that, right? The rules don't change. The rules don't change. Those are the rules. So when we're working with these guys, then same thing. Okay? Now, let me go back real quick because I want to point something else out, though. Let's say I had 2/3, and I was going to multiply that by 1/2. Yeah, that's what, 2/6? But there was something we used to do before, right? So that we didn't have to, like, at the end there was, if we did the 2/6, we would, what would it be? 2/6. What would we have to do at that point? Simplify, right? So that would become that. Or, before we even multiply, we could simplify then, couldn't we? You guys remember that? So what can we do here? Cross simplify the 2's. Because technically, here's what we're doing. We're doing 2 times 1 over 3 times 2, correct? And if you're multiplying, those are just factors, and anything on the top is fair game with anything on the bottom. So this 2 and this 2 make 1, and I'm left with the 1/3. You guys remember that? We're going to take the same ideas with this concept, okay? So, going back to here, before we get all crazy, be like, this is unruly, let's see if we can simplify that first, okay? So put those pencils down, watch me for a little bit, watch me do this one, I'll let you guys attack the next one, and I'll let you guys copy this as well, okay? So, here's what I'm going to do. I'm going to break this up into pieces, because looking at it, I'm already scared. I'm like, man, I'm doing what? So I'm going to start with this piece. Do they have a common factor? Yeah. I can factor out C, can't I? So that becomes c times c plus 2. Everyone cool with that? Now I'm going to go to the denominator of that one. Do they have a common factor? No, but they're both squares. And it's a difference. So I can factor a difference of squares, right? And those become conjugates. That would be c plus 2 with c minus 2. You already see what's going to happen here? What's going to happen? We're going to get a 1 with these guys, right? All right, cool. That's cool. I'm going to leave that alone. I'm going to come over to the other side. I'm going to multiply now. Let's go to this one. They don't have a common factor. Is it factorable? Is it a perfect square? Yeah, it is a perfect square, isn't it? That is a c minus 2 times a c minus 2. Do you see it? So I've got that. And then in the denominator, here, I do have a common factor. And that common factor is a c, isn't it? So I'm going to get c minus 1, because I took that c, right? So whatever's left is there. Now I'm going to see if I can simplify anything else. C. This c with this c is a 1. And the c minus 2, so this one with this one, what's left? C minus 2. And we're done. Yeah. Okay. Go ahead and copy that down and try the next one. I'll check back on you in a minute. A few minutes, actually. Do this. Try to do A by yourself again, and only look up to check. Let me erase this. Everybody already have this work?
Yeah.
All right, cool. Bye. All right, go ahead. It's hard.
Because when I went up there, you can't put your finger there. I write with my finger out too, like on the board.
Oh,
To get you sure.
to guide you.
Yeah. I could do that.
Can I stop you there for a minute? Thank you. I just want to point out something she did. Notice the denominator doesn't have parentheses there, does it? And she put them in. That's a really good idea. Because that way you know and you remind yourself, hey, that's one number. That's just one number. That way you don't try to get rid of pieces, kind of like that one mistake I showed you with the yellow slide. So that's a good thing to do. If you see something like that, put it in parentheses. Okay? Even if it is a polynomial, put it in parentheses. That's one number. Okay, hold on. What happened to the one?
Because this is the same thing, right?
Yeah.
Oh, okay.
I was just asking. You're being silly. Thank you. Nice job. Thank you. Cool beans. All right, move on. Yeah. Sorry.
Melissa asked if you could check it. Like, is there a way to check it?
No.
So, like, if you get the wrong answer, you're just wrong.
Yeah, like usually, because see, that's the thing here. We can check equations because we found something, right? All we did here is change the way it looks. We just simplified it. So there's no way to go back and do a personal check. So yeah, I understand what you're saying. Whenever you're manipulating expressions, you can't really do that too much. Okay?
Yeah,
Well, with the other one, with the domain stuff, we could, right? Because we found some values. Okay, we were looking for specific numbers. Here, it's just changing the way it looks. Okay? All right, cool. We're good? Right on. Okay. Find reciprocals of rational expressions. Find reciprocals. You guys remember what a reciprocal is? Okay. A reciprocal is when you have a numerator, Callie. So let's talk about a reciprocal real quick. Fractions have a numerator and a denominator, correct? Numerator, denominator. When you take a reciprocal, you are flipping it. You're swapping the positions, okay? That's a reciprocal. So, if I had a fraction called, what was it, 2/3? What is the reciprocal of 2/3? 3 over 2, right, because these would swap. So it would be 3 over 2. And yes, that's something you probably already knew. If I took these two and I multiplied it, some number by its reciprocal, what would I get? I would get 1. Okay? So nothing new there. Okay, so the reason we need to talk about that is because sometimes we'll have to divide rational expressions. You'll have to divide rational expressions. Kind of like 7/9 divided by 3/5. Okay? Right? Can you divide a fraction by a fraction? Or can you divide anything by a fraction? Not really. I mean, unless you were Einstein, right? But what we would do is instead of dividing, is that we would multiply by the reciprocal of the denominator. So 3/5 is the denominator. What I'm going to do is, instead of dividing is to multiply by that reciprocal, which is an equivalent expression. Okay, so this 3/5 here became 5/3, and instead of dividing, I multiply. It could have also been done this way, or presented to you this way. 7/9 divided by 3/5. Instead of dividing by that fraction, what you would actually do is change that division to a multiplication, and then take the reciprocal of the right side of the, what is it, dividend? Yeah, right? Divisor. The divisor. No? You're going way too back for me, Munoz? Yeah, right? Hold on, now you're gonna make, this is the quotient. Quotient. This is the dividend. Dividend and divisor. Right? Yeah? So this is what's going in there. So yeah, so that's a divisor. Alright, cool. Yay, math vocabulary. Alright, everyone remember that stuff, yes?
Yes.
We're cool with that? Alright, let's move on then. Let's do this. Here's my first problem. I think I'm going to go ahead and do that real quick. You guys go ahead and watch. I'll let you guys copy, just like before, and then you guys can do B. So looking at this first one, I'm just going to rewrite this and fix this. That is 5p plus 2 over 6, and I'm multiplying that by 5 over 15p plus 6. 15p plus 6. Now, that's a horrible 5. I can do worse than that. Is that better? A little bit? That's ugly too. But anyways, I'm going to try to multiply this, but I want to see if I can simplify it first. Because I don't want to do that at the end. It gets kind of weird. So let's see here. Is there any common factors here? No. I can't simplify that. This seems to have some common factors in it, though, doesn't it? Let's see here. What are the common factors? 3. So that would become 5p plus 2. Oh, that's nice. 5p plus 2 with the 5p plus 2. What's left in the numerator? The 5. And in the denominator, 6 times the 3, which is 18. I ain't gonna lie. I was gonna do a 3. Once you get A copied, go ahead and try B on your own. BET. Is that Black Entertainment Television? What's MTV? Huh? Music television? Music television.
There's not even like really any music on
It
it.
used to be anyway, now it's
Only
like,
at night.
they should change their entry reality show.
Like late at night. Like it's like 3 o'clock in the morning. There's still good music on there. Am I right?
Yeah, your chances are better.
It starts with
That really isn't. It's supposed to be. It's the purpose of seeing it.
I think they're trying to see if kids
was his fourth dollar. No, he has first. She has first one. Oh, that's not cool. Okay.
Sir?
You guys got it.
Yeah, you can take one cue. What would you get? Well, what's Q squared?
No, everyone got switched in the first one.
How do you break that up?
There is so many kids out there. Really? I almost hit a girl trying to open the door. That's my got a girl. So where I was coming out of Flutter and everyone was chilling out there. Knocked her out.
Well, take one cue out, so you're gonna end up with
Yeah,
one
because
cue
I was
for
walking
the
out
other.
to the front door because I gave all the money to my teacher. And I like
Zero.
knocked her out and I was like, oh, walked in front of the door.
What made me feel worse, it was like, because of the special ed kid. And it was
Like,
like,
if you take the cue out, well, like, what's left if I took one of those?
No, this girl literally got fight me because I did it. I was like, shit.
I just kept on walking and saying, but I don't know.
Oh my god. Well, it's common sense. Why would you stand by a door knowing that you're going to be able to go do that? I'm like, and then they're like, really? Well, why do you stand by the door? Like, it's a real question. It's their fault. When I used to walk from like second hour math first to government, I would just have like my hand out to make sure like doors would hit me. Because I have no choice but to walk on it. I do that too. If I make sure I'm like I have my hand out so like the doors and like one more time now when I came she like tore that door open and like it hit me and like pushed me back and I looked at her maybe next time you should look. And she was like, I'm gonna stand in front of the door and I found out you just like the flow of the rain and the traffic and all a little different.
Yes, but be careful. It's not gonna be the see how it's worse. So change the sign.
Just hold it.
So this was a Q plus Q, and then 2 minus Q. So you would have one positive Q and a negative Q. Yeah, that's exactly right.
I don't know if it's like a dying Wait, which one are you? The one here that right here. This one I'm thinking. I only know one. Yeah, I know the total, but like
I feel like it's
the one I'm thinking of is right. It's just like a picture. But
I like did it from here and then I looked up and I did it from that equation.
I don't know, but either way, I'm
Someone help you anyway.
never again.
Hey, you got it? You want to do it? All right, just because of time's sake, I'll go ahead and do it. You guys can check this, okay? In the top part, what can I do with that? I can factor out a Q because they have a common factor of Q. Oh, hell. So I would have 1 Q left over for that guy, and then the plus 2 over here, correct? And then that's just going to stay 5 plus Q. I'm going to change this to multiply, if that's cool with you guys. And I'm just gonna flop them in my head. So I got to do this one first, right? What's the common factor there? 3. So that's going to be 3 Q minus 2. And on the other one, can that be factored?
Yeah.
Yeah? How? It's a difference of squares. So, what do I put up front? The 2's. Do my plus minus, and what's the second part? Q. So, can we cancel it? Can we simplify anything out? What are they? I'll use another color. Go ahead. The Q plus 2. This one and this one are the same, right? So that's gone. Which one? This one? With what? Can they just simplify? Because if you look at them, that's a positive Q, that's a negative Q, that's a negative 2, that's a positive 2. So can I just make one? No, but I can make negative 1. Remember that rule? We just talked about it? When they're opposites like that? So what I'm going to do is I'm going to make this a 1, and I'm going to put the negative in front of the 3 there. Because I'm just going to get a negative out of that, aren't I? That's cool there? Anything else that can be simplified? Looks like we're done, right? So negative 3Q over 5 plus Q. Oh, Q's. Q's can go, right? No, because that's just a number. Okay? Put that in parentheses if you want. That's just a number. Nice job, Brandon.
Yay, we're done.
No, because.
Yeah, we are.
Yeah! Woo! Good job. You're so smart.
Oh my god. Why are you so excited right now? So early.
That's our first lesson of the semester.
Of the
You
year.
guys killed it. I was going to say year. Sorry.
Well, it is technically.
Technically,
Because we didn't see you since last year.
All right.
Wait, let me look at the date. What's today?
Homework will be on math lab.
Oh, I put 2016.
2K16.
Oh, put it up.